Hi everyone. NET-225 routers and switches. This is the work from Monday. This is the day I'm actually putting this together, the 23rd. Monday was the 22nd. We started out and we talked about switches, which we've spent a lot of work on. Based on layer 2, the switch determines which port the information can be sent out. So for example, if this PC is communicating to this PC, if it used an IP address, let's say an IP address, this one's 31, this PC could ping that number. It would do an ARP, right? Do an ARP, and it'll get the MAC address, and then that MAC address here would be there if this PC has communicated. If it hasn't communicated, then we see a broadcast, and once it answers the broadcast, but it will it'll answer the ARP and give its MAC address because the ARP is a broadcast, and so it'll have that, and then it can take the information, send it to there. Now let's look at in red if this laptop is what that LT stands for. If that wants to talk to this one, they're on the same network. All these devices up here are on the same network, let's say, however that's arranged. So then this port is going to have all of those MAC addresses eventually, if they're all up and communicating through this network. So this one wants to go to here, so it pings that number. Just as an example, the switch creates broadcast, gets that MAC address, assuming we're using Ethernet. This gets the MAC address and then sends it, and then the switch finds the MAC address here. So that's a little review. The reason we did the review is we want to distinguish how that's different than what a router does. In terms of a router, routing information based on a routing table. Looks it up the table and then picks an interface. Okay? Looks it up the table and then picks an interface. What would be on different interfaces? Well, advantages of a router. First of all, a router stops broadcast. Broadcasts don't go beyond these points. Okay? And also then the router can pick where to send it. So it's, I guess, why, broadcast performance is going to be better. I've got to be a little careful how we word that. It's, some people will refer to it as switching, but it's between layer, it's layer 3 switching, the network layer. And also, we can do some security in here. We can decide what traffic can go to a web server and what traffic can't go here to a PC. Or however you might do that, assuming this is like here out to the internet. And how does traffic, if this PC wants to go to the internet, how does a router know to send it out there? It can't have all the addresses of the internet, so it uses a, you should know this, default gateway. This picture, okay? Network. We can talk about the characteristics of a network. We talked about the default gateway. Why routing gives us the best path, forwards packets in the most efficient way. We create a routing table, basically two ways. We can create static routes, or it can learn them dynamically using routing protocols like RIP, EIGRP, or OSPF. We usually use a combination of both of these. Okay? We refer to a packet, okay, where it's going to go and out a particular interface. The router looks at the IP in the packet, and it gets a little more complicated than that, but for right now, it's all what we're going to worry about. We talked about putting a loop back. There's a loop back in your NIC card. You could ping this to see if your workstation's NIC card is working. We can also use it for testing. You can make a loop back in the router. You can load balance. We'll talk a little bit more, but that's if you have two options out of the router that both lead to the same place eventually. You could send some of the information the blue route, and you could send some of the information the red route, or one way or the other. So that's load balancing. Administrative distance, you can put an administrative distance on a static route, and there's built in for dynamic routes. 120, OSPF 110, ERGP 90. When we think of best paths, and later on we'll talk about metrics, it's the lower numbers the best path, the least cost. Let's look at another slide and see. For example, out here, if this router in the internet was trying to decide, should I send the traffic this way or should I send the traffic this way, it's going to pick the least cost. Now, BGP, Border Gateway Protocol, version 4 is what I think they're still using on the internet. You could look that up. But that's a routing protocol. And so we talked a little bit about, if information from here needed to go to here, we could review load balancing. If they have two accesses into the internet, two ISPs, you could send some of the information one way and some of the information the other way, even packet by packet. We'll learn more about that later on. All right. So, to finish up, financial aid is due by March 1st. We took the first take of assessment for Chapter 4 today. The students worked on this lab. We did Part 4 together in groups, and that was pretty much complete. Wednesday we'll finish up Chapter 4. We'll start Chapter 5, Inter-VLAN routing. And we'll take the Chapter 5 first exam next Monday. That's it.